Alright, welcome to Chemistry Video 4.2. Here we're going to define what the atom is. Main objectives: define the atom, be able to distinguish some of the subatomic particles that make up the atom in terms of their charge, their mass, and also including their location. When you're all done today, you should also be able to know what the structure of the atom looks like. Alright, prepare yourselves, get rid of your cell phones, your social media, pause, rewind as you need to, and take some extra notes in the margin should you need to. So, what is an atom? Well, atoms are the basic unit of matter. There are 118 different elements which you can find on the periodic table. And atoms we cannot see with the naked eye. You can't see them with a microscope or an electron microscope. You can only see them with an STM, which is what stands for a scanning tunneling microscope. It's a special type of microscope that has a very fine tip, and as it goes across the sample here, remember that there's atoms in the sample on the surface there. As that fine tip goes across there, it has a little electrical conductivity reading that measures like the difference in electrical output, I guess. And if you remember from last year, the atom is made of an electron cloud going around there. And essentially, because it's made of electrons, there's a little bit different current as you go through the peaks and valleys of the surface of the atoms there. So it kind of makes a little picture there. And then some kind of computer display is created showing what you have there. So scanning tunneling microscopes look something like this. Here's, I think they got 15 gold atoms arranged like billiard balls there, and you can kind of see the peaks and valleys. You can even see like the subsurface here, the blue area, where there's still peaks and valleys, and you can see some of the atoms there. Then some companies got a little creative here, and they were able to spell their name out, IBM. Another group got really creative here and wrote, "If you can read this, you are too close." So this is what a scanning tunneling microscope does. It allows us to kind of see what atoms look like. So the atom, we should now know, is not the smallest particle anymore. Atoms can be broken down still. The atom is the most fundamental particle, which is what we really care about in chemistry for the most part. But we do also care about them, what they're made of. So the subatomic particles, which means below, particles that are smaller than the atom, there's three of them. And there are the proton, the neutron, and the electron. And I'm about to go through some different slides here, as you can kind of see quickly here, that goes through some of the different experiments leading up to the atom. We'll eventually get to this slide here, and then you'll record some things. For now, just kind of watch through this and listen, and maybe answer a couple questions along the way as well. So, the first particle discovered was the electron by J.J. Thomson. And J.J. Thomson discovered the electrons by using cathode rays, which we'll show in a second here. Cathode rays were basically found to have negative charge and little mass, just like electrons. They have a negative charge and little mass. So let's kind of watch a quick video here on the discovery of the electron with the cathode rays.
Okay, this is a cathode ray tube. What it essentially is, it's a vacuum chamber. There are no gases inside this glass tube. The only thing we have are two electrodes. One's called the cathode, the other's called the anode, and a fluorescent screen in the background. It's coated with some type of fluorescent material. When I turn the power supply on, we'll see a beam that causes that fluorescent screen to glow. Looks like a nice straight line, doesn't it? We call that a cathode ray because it emanates or begins at the cathode and shoots across over to the anode. J.J. Thomson was working with cathode rays. We really didn't understand what they were. I mean, we have electricity going in one side and coming out the other, but there's nothing inside to conduct it. It's a vacuum tube. So he decided to apply a magnetic field to this cathode ray, and he found something interesting. We apply one pole of the magnet to this beam, and we'll see what it does, and then we'll flip it around and see what the other pole does. This is my favorite part. Can you see what's happening to that beam? What does it appear as though it's happening to it?
It's moving.
It's moving. It's being repelled, isn't it, by the magnet? When we flip the magnet around, and what do you think is going to happen this time? Well, if it's being attracted on one pole, see how it's being attracted there? Let me rotate it so the kids on this side of the room can see it. See how it's being attracted there? And then the other pole, do you see how it's being pushed down? What does that tell me about that beam? It has a what? It has a charge. Let me tell you about the poles of the magnet. The one that pushes it away is the negative pole. So what does that tell you about the charge of those particles? negatively charged particles. And J.J. Thomson was actually able to do a charge to mass ratio of these particles, and he found that these particles were about 2,000 times lighter than a hydrogen atom. Now at the time that was very profound. What did Dalton say? Are there any particles smaller than an atom? J.J. Thomson just found something 2,000 times smaller than a hydrogen atom. Why is the hydrogen atom and something 2,000 times smaller than it so profound?
Hydrogen.
Because hydrogen is the smallest atom, isn't it? So if we found something 2,000 times smaller, we have found our first subatomic particle. And it's called the electron.
Alright, so that's a little bit about the experiment on the cathode rays that led to finding the electron. Quick answer to the question on Edpuzzle here. Alright, up next was Ernest Rutherford and his gold foil experiment. This experiment led to discovery of the nucleus and then eventually the proton. Let's go ahead and watch the quick video on this one here.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus.
Alright, and so that's the gold foil experiment. Some big ideas here again. So we're shooting positively charged particles at this beam of gold foil, and basically a lot of particles go through and some get deflected there. Okay. The reason about the traveling through here, most of those positive alpha particles travel through, like these arrows here and these ones here, is because most of an atom is actually made of empty space. The yellowness here represents empty space where nothing really is. We now know the electrons go in that empty space there, but it's mostly empty space. If the electron's here, the rest of this is considered to be empty right now. And then the reason that some particles deflect is because atoms have a dense positive core, the nucleus. And if this thing was a negative charge here, and you shoot positive particles at it, they would stick together. But because the nucleus has a positive particle there, the proton, when it gets close to it, actually repels off of that, or deflects off to the side like that one there. The previous model basically said the atom was a nice solid piece of material, and basically now we know that atoms can travel all the way through it, whereas prior to that we didn't think they could travel through. Up next was the discovery of the neutron by James Chadwick. He used some radioactive experiments to discover them, and we're not going to go much more beyond that, but I'll kind of show what he did here. He basically took some nuclear mass stuff and he tried to make them combine together, and they did combine together, and they make this. Well, there's this extra little chunk of particle that falls off, and basically that particle that was falling off had no charge. It was not positive or negative. It had mass, so therefore Chadwick had discovered the neutron through his experiments. So, at this point in time, let me give you the quick little lowdown here. You need to make sure you know all the information here, who discovered what with what experiment, what our symbol is for the different types of particles, P with a capital with a P with a superscripted plus sign, E with a negative sign up there, N with no sign. Know the location, the charge, everything, and we'll kind of go through some of these things in class as well. You don't really need to know this particular role by heart, but everything else you should know in here by heart, and we'll have a little quiz on this coming up. So, pause this and record this into your notes now. Alright, super duper. Let's just kind of wrap it up here now. So the atom, okay, is spherically shaped. Atoms are spherically shaped, and the electrons move in the electron cloud, which is mostly empty space. So this would be your electron cloud here. And we make it look fuzzy because the electrons are moving around so fast, it's kind of like they blur through here. They're moving around so fast somewhere in that area there. In this tiny little spot in the middle here, and this doesn't even do justice, this thing is much smaller than you can see here. Analogy I remember from my high school days is imagine a marble on the 50-yard line of a football field, and imagine the entire stadium. Okay, if you had a marble at the center of a football stadium, that'd be roughly the size of the nucleus, and then everything else there is technically empty space around there. So the nucleus is very dense. almost all of the mass is going to be found there, and that's where you're going to find the protons and the neutrons. Lastly, just kind of take a step farther from protons, neutrons, and electrons. Scientists have determined that protons and neutrons can be smashed into even smaller particles, which they have kind of collectively called quarks. At this point in time, I should say we actually do know more about those, but in terms of what they mean to us in chemistry at this point, they don't really help us too much at our chemistry level. If you want to be a quantum physicist and learn more about those, that'll probably do a better job explaining the behavior of matter. But until then, we learn more about that and roll into a chemistry class. Atoms are doing the job until we learn more. So that is your little video on the structure of the atom.